Hello, everybody. Well, hello, Richard, because I'm on my own right now, as many of us are. I'm going to talk to you in the next 15 minutes or so about an ARDC funded project looking at the Australian Digital Observatory, which is focused on capturing a wide array of social media data across Australia and providing a range of tools and analytics for the broader research community. If Melbourne is like anywhere else around the country, then the university has, I guess you could say, something like a cottage industry in dealing with social media. Lots of groups have been doing their own thing for some time, collecting some data on certain topics, whether it's Trump or COVID or some specific theme that they're interested in. And that works quite fine for a while up until their laptop is full and they can no longer access and use more data, and they get swamped by the amount of data and they can't analyze it anymore because they may or may not have the expertise in-house to be able to process voluminous amounts of data and to do a range of richer analytics around it with applying natural language processing tools or advanced visualization, etc. My team, and I guess the focus of the Australian or the ADO project, has been to collect a lot of this data. We've been doing this for some time now, since 2014, give or take, and we have been using the programmatic APIs that are available for many of these platforms and collecting data for a range of research needs, both for myself and the projects I'm involved in, for teaching. So I teach cloud computing, and we've used social media as one of the primary data resources for the last few years in to show how you can do big data processing on the cloud using technologies like Couch Database or Hadoop, etc. Social media, as many of you know, there are many platforms that are out there. At least in the initial instance of the ADO project, we've been working on a range of platforms, any platforms with an API effectively. So this is Twitter, Reddit, YouTube, Flickr, Foursquare, and as well as e-gaming platforms like Steam and Valve, where if you or your children play League of Legends or Counter-Strike or Borderlands or any of these platforms, they also have APIs to extract the data and to understand what people are playing and how long they're playing for, etc. There are many other platforms, though. Obviously, we have, LinkedIn, Facebook, TikTok, Snapchat, and others, both internationally as well, like the Weibos of the world, etc. They don't provide an API, so we are not scraping them. I mean, I've done my team have done various work previously in scraping websites, and it's nowhere near as good. And so we are not bothering in that here. It's also against the spirit of what we're trying to achieve with a structured sort of ethical process to collect data. Some platforms like Instagram, we were collecting. They had APIs that we could access and use, but since Cambridge Analytica happened, then we're no longer collecting that data. Just to give you an idea what, the scale of the data that we're dealing with. So Twitter is probably the most common platform that various people are accessing and using. We have maybe just under 3 million people using Twitter in Australia, and it's used both by the complete spectrum, I guess you can say, from young people tweeting about random topics to funding agencies. Indeed, I'm assuming that many people who are attending eResearchOz Australasia are tweeting about talks, etc. So it's a very diverse community, and it's a very active community. The actual data itself, a tweet in the case, there's a lot more information that is being released when people are tweeting than in the actual character strings or the images that they are sending. It will include things such as, who you follow, who follows you, your location at the time, if your location's turned on, whether you're using an Android phone, an iPhone, etc., etc. And that whole extra information gives rise to a range of privacy issues, both where you are, where you travel to, which groups you're in or who you connect to. And all of this can be used to provide content for advertisers to do personalized marketing to you, as well as government agencies and businesses to profile every one of us that are using these kind of platforms. Historically, Twitter had an APIs. They have a streaming API and a search API. And the streaming API would give you maybe 300 tweets every 15 minutes or so. And the search API you could use to say, give me tweets on topic X or from account Y, etc. But we were only ever getting a very small amount of data, maybe 1% of the tweets, and only the tweets that were sent in the last 10 days. So if you connect to, say, to Twitter streaming API and say, give me tweets for Melbourne, I mean, you can put a bounding box or a radius around the area of interest, and it will get data for those areas. But you only get data within the last 10 days. As of this year, Twitter are making now available the full tweet archive, where you get much more data now, and it can be historic data too. So we're getting more data than ever before from platforms like Twitter. There are many, many use cases that my team and my students and others no doubt have explored in this context. So we've done lots of different things. On the right-hand side, you can see you can identify events in crowds. So predicting goals happening in a famous soccer match of Brazil against Germany was one example. Looking at how people move around the city is another example. People tweeting some part of the day, and then later on somewhere in the day, clustering them together and working out how people are moving around the city. Clearly, health, how with the pandemic we're all experiencing, is a very, I mean, social media plays a very big part of the ongoing discussion around COVID and vaccines, etc., and what the public are thinking about the lockdown and things of this nature. So there's a range of use cases of the data. So what the plan is for what we're building will be a front-end dashboard where you can select areas of interest, maybe Melbourne, Sydney, Brisbane, etc. You can look at the top topics that people are talking about in those areas. You can see are people happy or sad. There'll be dashboards which are being prototyped, which shows you how sentiment is changing over time, or the topics are changing over time. All of this is being deployed on the national cloud, Nectar, and using a range of big data technologies, which I don't really have time to go into, but we've been doing this for some time. Suffice to say that we're using a clustered CouchDB database solution where we have the database running across 3 servers, and it's running 24/7 effectively, collecting more and more data from Twitter, from Reddit, from Foursquare, Steam, etc., etc. One thing to mention as well is that in due course, we'll have various other functionality, including the ability for people to request access to data, as well as the APIs themselves, which will give you summarized statistics and information, say how many tweets on specific topics in certain areas, as well as potentially running targeted services through the infrastructure that we're in the process of building right now. Just to give you a feeling for where we are right now with the data that we're collecting. As I say, my team have been collecting data since 2014. So we were just getting some data just to use for some topics in teaching, cloud computing. Since 2017, we really started ramping up, collecting a lot more data from a lot more platforms. We have 200 virtual CPUs, which have been, this is the actual infrastructure now on Nectar for the big Twitter project, as we call it. We have an allocation of 200 virtual CPUs. We have 50 terabytes of storage. We're slowly filling that up. The primary data resources we have right now are in Twitter. We have 364 million tweets, and that's growing by another 10 million every few weeks. We have Instagram, where we were collecting, but we since stopped. And now we're starting to build up, the assets related to Reddit, especially, as something which is of interest to many researchers, and especially the threads and things such as fake news. And when people are talking about topics like vaccine or anti-vaxxers or things of that nature, we're collecting lots and lots of resources in this space. Just to give you a bit of a feeling for what's possible to do with this data, this is just some of the high level, we do a range of natural language processing on the data. So we can take the posts and the tweets. We can get rid of all of the if, the, stop words, I guess. We then provide a range of, create a range of vectors from the data using terms which are related to lockdown, and then provide a range of analysis around this. So we have, and this is showing you the terms and the topics per week and how they're changing. So anything that is related to lockdown, so we have COVID, outbreak, spreading, restrictions, etc., and how the vocabulary about what's being spoken about online is changing between at the end of June and the sort of mid-September period. So you can sort of see what the public at large are talking about on these topics. You can then see what the sentiment of the population is like using, say, taking a tweet. And if it's a happy tweet, it might get a positive sentiment. If it's a negative tweet, it gets more of a negative sentiment. So between +1 and -1 typically. And so here you can see we have a, generally speaking, a negative trend in lockdown. So people, I mean, when lockdown is ended and people are allowed out, there might be spikes in the traffic, but generally speaking, people, as you can imagine, are not exactly super happy with the whole lockdown, with Melbourne especially leading the world ranking now and how long people can be locked down for. We can do similar things with other topics. So like looking at things like protests, you have rallies that are taking place, you can have riots, you can have Dan the dictator, etc., etc. There's a whole range of vocabulary that people are talking about in that context. Again, generally speaking, we have negative sentiment. So this is neutral. So we're very much in the negative sentiment area. Vaccine is a similar scenario. You can look at, what terms people are talking about in the context of mentioning vaccine. And just to say that this is the actual term. This is when it's vaccine or vaccination, etc. It gets stemmed, gets reduced to a certain term, which is then used as the basis. That's kind of, it's not a typo. Again, you can see the variation in sentiment, the sort of mood relates to the term vaccine and how that generally is negative, but occasionally it goes a bit more positive, right through to things like the economy or economics. And so you can sort of see here, we have a range of topics which people are talking about, billions and debts and tourism and pandemic and cost and livelihood. And it shows you the increasing sort of, I guess, frustration for many people about the impact on the economy by the lockdown and COVID, etc. Here, however, we have a slightly different sort of perspective. The negative is not all negative. The sentiment is not all negative. It changes quite drastically. So this might be due to JobKeeper announcements or job seeker announcements and things of that nature. So it's not all doom and gloom when it comes down to the economy as a result of in the last 3 months. Scott Morrison, or ScoMo, as his nickname is online. There are a range of topics which I won't go to in very great detail, but suffice to say that the people have a very mixed to very negative opinion of him in social media, which is kind of part of the challenge of social media, where everyone has an opinion, they throw it out, and this is kind of the language that is typically being used to express this. And as you can see here, the general sentiment is pretty negative overall for Mr. Morrison. What else? So this is just the raw data and just producing topics and doing sentiment analysis. There are a range of additional layers of maturity in what we can do with this then. So for example, as people probably know, we have this ever-present problem of fake news. So someone tweets something which gets retweeted and liked, etc., by different users. And then someone says, no, that was wrong. This was not, a child was killed for stealing sweets, etc. And then later on says, no, that's got nothing to do with that. So there's a range of challenges in all this information online and how much truth or veracity do we assign to it. And so we've been building various tools and models in this space to be able to tag data as potentially fake. So there is a range of machine learning, linear regression, or support vector machines, right through to more recent sort of approaches from Google, which have been training models to identify patterns in the data using data that we know is fake. And so there's a range of databases now that have been established, which are in the fake news space. And we train models to identify the patterns in those data sets to then say, okay, when we see other data that we're collecting, can we I give them a score of how similar they are to fake news. So that's actually in the text. There's a range of other techniques as well. So for example, you can look at the pattern of dispersion of news online. So fake news generally becomes viral very quickly. It gets sent out to many people. There is generally a community of people who will like it or retweet it. And identifying these networks and the way in which they forward on information is part of the fingerprint, I guess you can say, of being able to identify news as being potentially fake. And so in this recent work with some students, we could identify 82% of the time that a given news item was actually a fake news item. I have other grants in this space as well, including the National Intelligence Security sort of discovery grants, which we've been given more resources for specifically identifying this topic, looking at disinformation detection effectively. So where are we right now? We are collecting data. We have been cleaning data. We're in the process of building a dashboard and developing APIs for access to and use of this data. Part of the challenge of this is the licensing of the data and access to and use of the data, and also the privacy of the data. So each social media platform has their own terms and conditions on access to and use of their data and potential redistribution of the data, which is something that we're looking into. This builds upon a report that was put together by QUT. At the University of Melbourne, I've been asked to complete a privacy impact assessment, identifying the privacy implications of having this data and what can we do with it. And it's very easy to do bad things with social media data, identifying where people go, where they are, even at being able to identify traffic jams by people tweeting on the motorway. And in one way, yes, it's kind of interesting, but in another way, they're all committing a crime by using social media. Typically, if they're driving, I mean, okay, they could be a passenger or on a bus, but it's these kind of issues which social media gives rise to that we've never really had to solve before, I guess. Just in terms of the project more generally, there is a sports outreach and engagement team with QUT who are involved in the project, as well as UNSW. Sorry, I should have said this at the outset. And that includes leveraging resources from the Australian Text Analytics platform and the time layer cultural map. And that was the end of the talk. Thanks very much.